Hello, Untitled class. This is your notes for section 110, modeling with functions. So this is a kind of a nice, gentle way to say word problems. Modeling means we're coming up with some type of an equation that describes some real phenomenon that we're dealing with. Okay, this is what your part of your functions project will be on. Is some of the stuff that we're doing in this section. Okay, we'll have some software to help us do it, where we're not just given a scenario and have to come up with it on our own like this. But this is kind of the backbone to what it is that we're going to be doing for that project. All right. So this first example, we're given a verbal description of some type of scenario. So this is a texting plan. This one has this fee and 5 cents per text. This one has $5 fee and then 10 cents per text. So we're wanting to come up with, for part A and B, the cost for each plan. So for part A, plan A, we have a monthly fee of $20. So I'm going to do cost X. All right. The cost here is $20. I have to pay $20. Plus 5 cents per text. And the way we do that is, you see this per, something per, it says here express, it says F, sorry, I'm writing C. It says to express our function in terms of X, where X is the number of texts each month. So if X is the number of texts each month and it costs 5 cents per text, this right here, we've said before that per a lot of times means divide, but it also can mean multiply, and that's what it means in this case. We get charged 5 cents times the number of texts that we send. So if we send 10 texts, 5 cents times 10 is 50 cents. If we send 20, 5 cents times 20 is $1. So that's what the per is going to signify in this case. Okay, and then B, plan B, they want us to use g of x for cost. And g of x has $5 as the fixed cost, plus we have to pay 10 cents instead of 5 cents for every text. Okay, I could have put 0.10x, but that's the same thing as 0.1x. Alright, so there's our two cost functions. Now, part C says, how many text messages will the cost of the two plans be the same? Two plans be the same. So that just means set these two equations equal to one another and solve. So now you're back in like an algebra 1 class, and you're solving just a linear equation. All right. So I'm going to move the x, the 0.05x over here. I always move the little one over to join the big one. So I get 20 equals 5, and then 0.1x minus 0.05x is 0.05x. Okay, and then subtract 5 from both sides. 20 minus 5 will move over here. 20 minus 5 is 15. Right, the 5's cancel here, like the 0.05x is canceled there. And we're left with just a 0.05x on the right side. All right, and now we're just going to divide 15 by 0.05 to get the x isolated. That's 300. So x equals 300 texts. Okay, so that's how you do a problem like this when you have multiple plans and you're wanting to see when they're equal. Okay, some of the types of problems you may see here is, for how many texts will one be better than the other one, and then we would just change this, instead of an equals, we would have like a greater than or a less than. Alright, here's another type of problem. Again, it's a translation from word problem to an equation. It's the big thing that you're doing in this whole section. But we have an airline that carries 6,000 passengers per month, and they pay $200 each. Okay, a market survey indicates that for each time you increase the price $1 in the ticket price, the airline will lose 100 passengers. So we're starting off with 6,000, and we're going to lose 100 passengers for each dollar this thing goes up. Okay. Express the number of passengers per month N as a function of the ticket price X. Alright, so what we're going to start off with here for A is use N sub X for our function notation. Okay, here they're telling us what they want the name of the function to be. And then we're going to use this. $200 is what they're paying right now. So $6,000 passengers are is the current number. Okay, and they're paying when they're paying $200. Now we're going to lose 100 passengers, so I'm going to write minus 100 for each dollar increase in the price. So right now it's $200. So if X is the price, if it's the ticket price, then X minus 200 is the increase in the ticket price. So for instance, if this is 210 minus 200 is $10 is the increase, and for each dollar increase, it's increased $10, we're going to lose 100 passengers. So 100 times 10 is 1,000. So 6,000 minus 1,000 is 5,000. Okay, so X minus 200 is the increase in the price. Okay, that's the number of passengers they lose for each dollar increase, and then we subtract it because it's they're losing 100 passengers, so that's why we have the minus 100 here. All right, and I'm going to erase this. There's part A. That's how many passengers per month that they would have. Okay, now you may be thinking, well, what if that's bigger than 200? What if it's 190 rather than 200? Well, then that would be a negative number, and a negative times a negative is a positive. We would actually add customers rather than lose them. Okay, so it's fine as long as you have this set up the right way. Okay, it has to be X minus 200 rather than 200 minus X, because we do want this to be positive when the price goes up, so it decreases, and then it would be negative if the price went down, so the number of passengers would increase. Alright, then they're going to want something like this simplified, get rid of the parentheses. So if I distribute the negative 100 through, I get 6,000 minus 100x, and then a negative times a negative is a positive, and then 100 times 200 is 20,000. Okay, and then we just combine our like terms. We got a negative 100x here, and then plus 6,000 and 20,000 is 26,000. Alright, so that's the number of passengers we have as a function of the ticket price. Alright, and then part B says the airline's monthly revenue for this is the product of the number of passengers, this is the number of passengers, and the ticket price, which is, remember, X. So the revenue function, again, they want us to use R, how much money they make, is equal to the number of passengers, which is the function that we just did, times X, the number of tickets they sell. Okay, that's what it says right here, the product number of passengers right here. Alright, so I've highlighted number of passengers in yellow. This is the number of passengers from the last problem. Right, times the ticket price. There's the ticket price. Okay, remember that was what X represented. Alright, and then again, simplify it. So again, we got a sum. We're going to distribute the X through, so that's a negative 100x squared plus 26,000x. Okay, so there's our revenue function. And if you're a business major, or if you're thinking about becoming a business major, one of the things that you would want to know, and you would do in a calculus class, a business calculus class, is find the maximum revenue.